So what do we got tonight to work on?
Properties and exponents.
Okay, good. Everybody else been telling me probability and statistics. No matter what they're taking, it's probability and statistics time.
Yeah.
Okay? So what kind of problems you got?
Okay, first one is in parentheses, -2. And on the outside, it's to the exponent of -5.
They want to know what that's equal to?
Yes. It says evaluate the expression.
Okay. First of all, tell me what this is equal to.
Isn't that like 0?
No. It's whenever you see a negative exponent, merely means the reciprocal. Like that.
Okay.
If I had 3 to the -4, that would be the same as 1 over 3 to the 4.
Okay.
Okay? Don't make the mistake that a lot of people do of assuming that negative exponents mean negative numbers. They do not. In other words, notice that that's equal to 1/2. In fact, as long as the base is positive, the negative exponent is not going to be a negative number. It's always going to be a positive number. So there's no relationship between that negative exponent and negative numbers.
Gotcha.
Okay? So what does -2 to the -5 mean?
Would it be 5 over 2?
That would be 1 over -2 to the +5.
Oh, okay. My bad.
You see why? And I do need parentheses around that. That actually has a different meaning than the other.
Gotcha.
What the heck's going on with my... What in the world? Here, let me close this thing out and open it again. It's acting up on me.
That's fine.
Yeah. Okay. So the problem was -2 to the -5, right?
Yes.
Okay, so that's 1 over -2 in parentheses to the -5. Well, what's -2 to the -5 power? Or excuse me, to the +5.
-2 to the +5?
Yeah, in other words, what we started with was -2 to the -5. So that's going to be equal to 1 over -2 to the +5, which is equal to 1 over, what is -2 to the +5 power?
Would that be +10?
No. What is 2 cubed?
2 cubed, that's 9, right? No.
8. 2 times 2 times 2. What is 2 to the 4th?
16?
What is 2 to the 5th?
32?
What is -2 to the 5th?
-2 to the 5th. Would that be -32?
Very good. So -2 to the 5th is -32, which means that's our denominator, -32. Which means our answer is -1/32.
Gotcha.
What else you got?
Okay, this one is 2 to the exponent of -4. It's not in parentheses.
Well, the parentheses don't hurt.
Okay.
And it's better to use parentheses too much than too little.
Okay.
In other words, this means 2 to the -4, but if I put parentheses around it, it still means 2 to the -4. Okay, so it doesn't hurt. Now, if there was a negative sign in front of there, then the parentheses are very, very important. In other words, they're needed if they are needed. But my point is that you can't overuse parentheses and you can underuse them.
Okay.
So 2 to the negative 4, first of all, means what?
Well, that's not the full thing yet.
What's that?
It's over 4 to the power of 0.
All right.
My bad, sorry.
That's all right. What's 4 to the power of 0 equal to?
1, isn't it?
Uh-huh. So you were correct in the first place. Same thing as this.
Oh, okay.
All right. So what does that mean specifically? 1 over what?
That's negative 16.
1 over what?
Oh, sorry, my bad. To the negative 4.
No. In other words, that can't be. Notice that that's impossible because that is the same as that. Well, once we put it in the denominator, it's got to have a different sign. That's the truth right there. 2 to the negative 4 power is the same as 1 over 2 to the positive 4 power. Okay, what's 2 to the 4th power?
16.
There's your answer. So that is the only thing you need to do with a negative exponent. Even if I make it a variable, 2 to the minus x, that's the same as 1 over 2 to the positive x. So the negative exponent has nothing to do with negative numbers. It has everything to do with reciprocal.
Okay.
Okay? All right, what else?
Okay, this one says, simplify the expression.
Okay.
First one is x to the negative 7.
Keep going.
Or
is that it?
That's it. That's it.
Okay,
Yeah,
what's that equal to?
I'll just be 0.
No.
Over x to the power of 7.
There you go.
Okay.
That's what that's equal to.
Oh, okay. So that's
simple as that. There's nothing complicated about it at all. When you see a negative exponent, just make its reciprocal with a positive exponent.
So if it was like y or x to the power of 0, would that just be
That's
x
a little
or y?
different. Any number to the power of 0 is 1.
Okay, so even if there's an exponent, the exponent really doesn't matter?
If, no matter what the number is, in other words, even this is equal to that.
Okay.
So it does not matter what x is. I could say 117,000 to the 0 power is equal to 1. Every number, no matter what it is, raised to the 0 power is equal to 1.
Gotcha.
All right. What else?
Okay, the next one is 9x to the power of 0. Y.
First of all, is the 9x in parentheses?
No.
Okay, the parentheses is just around the x, or it's like that?
It's like that. But then after that, it's y to the power of negative 3.
All right. Let's take this piece by piece. The
Okay.
number is 9. What's that equal to?
1.
What's this equal to?
Would that just be y to the power of 3?
1 over?
Y to the power of 3.
So this whole thing becomes 9 over y to the power of 3. See that?
Yes, because you multiply it by 1.
Exactly.
Right?
In other words, I replace the x to the 0 by 1.
Okay.
And it matters a lot if the 9x was in parentheses, because if I say that, then that whole thing's equal to 1. Doesn't matter what x is. No matter what x is, if I take 9 of it to the 0 power, I get 1.
Okay. Okay, this one is 15c to the power of negative 8, d to the power of 0.
Okay, number doesn't change. What is c to the minus 8th?
It's going to be 1 over c to the power of 8.
What's d to the 0?
1.
Don't even need to put it in there. There's your answer.
Okay. The next one is 2 to the power of negative 2, m to the power of negative 3, all over n to the power of 0, which is 1.
Right.
Okay.
Replace that with a 1. What's 2 to the negative 2 equal to?
2 to the negative 2, that's 1 over 2 to the power of 2, right?
Keep going. Keep simplifying.
Which is 4.
1/4.
Oh, 1/4, my bad.
It's all right. You knew it. And then what's m to the minus 3 equal to?
Let's see. It's going to be m to the power of 3.
The numerator or the denominator?
Oh, denominator, my bad. So it's going to be 1 over...
That's all you have to do.
So the 2m does not matter?
The what? The 1?
Oh, my bad.
No, the 1 doesn't matter because it's in the denominator. So, you know, I could put, okay, we're multiplying everything by 1 here. If it, I like it better. The key here is what to do with negative exponents. If you can remember what to do with negative exponents, and it's not hard, it just means reciprocal of the positive exponent. However, there's a couple of things that are interesting. What if I do this? What's that equal to?
That'll just be 1. Oh. Will that just be 1 over the power of that would just be 2 3.
Yeah, 2 to the 3. In other words, whenever you have a negative exponent, you can just move that term to the other side of the fraction bar, and you have your answer.
Oh.
In other words, 2 to the minus 4, I'm going to move the 2 to the other side of the fraction bar and make it a positive 4. In other words, you change the sign on the exponent and you move it to the other side.
Okay.
So if I had something like 4 over 2 to the minus 3, well, that's equal to 4 times 2 to the positive 3.
Gotcha.
And it's as simple as that. Negative exponents, just move them to the other side of the fraction bar and change the sign on the exponent.
Gotcha. Okay, this next one says the area, it's a word problem. Okay, the area of the rectangular computer chip is 112 a to the power of 3 b squared square microns, and the width is 8 ab microns. What is the length? Oh, my bad. It's 112, not 112.
So the area is 1/12 a cubed b squared.
It's not 1/12, it's 112. My bad.
No problem. So the area is 112 a cubed b squared.
Yes.
And the width is 8 ab.
Yes.
Okay. Well, let's call this x, since we don't know what it is.
Okay.
So I could say that width times length is equal to this area.
Okay.
So I can say x times 8ab is equal to 112 a cubed b squared. You get that part?
Yes.
Okay, let's erase that so I have room to write. So now all I have to do is solve this equation.
Okay.
So what's the first thing I can do? In other words, I want to solve it for x in
Mhm.
terms of a and b. So what do I need to do?
Um, First, don't you want to? Oh, could you distribute the x?
No, that's usually, remember we're solving for x, which means we want
Okay.
to isolate that. So
So
distributing it would be going in the wrong direction. In other words, if I distributed it, I would have 8abx. Well, I'm
okay.
trying to isolate it. So I don't want to
Okay.
distribute it. What do I want to do?
Would you subtract it?
What's it currently doing? What is the current? What
Oh,
is
it's being
8ab currently
multiplied.
doing? It's multiplying, right? So what do
Yes.
I want to do to move it?
Divide.
Divide. Divide by
Okay.
8ab. Okay, what's that leave on the left side?
X.
That's what we're trying to solve for. What's 112 divided by 8?
I do not know. I have to look. Oh my.
14. 8 goes into
Okay.
112 10 times with a remainder of 32. 8 goes into 32 4 times.
So do the exponents not matter then?
Well,
Or?
hold on. No.
Oh,
What we're going
okay.
to do is handle each term at a time. First of all, I'm going to handle that one.
Okay.
All the numbers. Next, I'm going to handle the a's. Well, what's the net of that?
The power of 3.
What's a cubed divided by a to the first?
8 to the power of 3.
When you're dividing, you subtract the exponents.
Okay, so the x to the power of 2.
A to the power of 2.
Gotcha.
And we're going to put it in the numerator because the numerator is bigger than the denominator. How about b?
B
What's
b to the power of 1, right?
what? B to the what?
Power of 1.
Yeah. So there's your answer. In
Okay.
other words, these problems aren't hard. They're just, you take one term at a time. You take the numbers, you do those. You take the next letter you run into, you do it. Take the next letter you run into, and you do it. Now,
Gotcha.
what is this?
Would that be a to the power of negative 1?
It is, but a lot of times they will tell you they don't want any answers with negative exponents.
Then would it be 1 over a to the power of 1?
Very good.
Or just 1 over a?
1 over a, exactly.
Okay. Awesome.
What else?
Okay, I'm not that great with scientific notation.
Okay.
But this one says, evaluate the expression, write your answer in scientific notation
Okay.
and standard form.
Okay.
So, the first one is, in parentheses, 3 times 10 squared. Sorry about that entire thing is in parentheses.
Okay.
And then after that, it's times, so next set of parentheses, 1.5 times 10 to the power of negative 5, end of parentheses.
Okay. Again, you want to take each piece separately. We want to multiply the 3 times the 1.5. What does that give us?
3 times 1.5, that'd be 4.5?
Uh-huh.
No. Oh, okay.
And then we want to multiply the 10 to the second times the 10 to the minus fifth. What does that give us?
10 to the second. Wouldn't you just, would you add the 2 to
You
the
add the exponents. So what is 2
Okay.
plus a minus 5?
minus 3?
There's your answer. Now, let's talk about negative or scientific notation for a moment.
Okay.
What does this mean?
3 times 10 to the power of 2.
What's 10 to the power of 2 equal to?
10 times 10, 100.
That's all that scientific notation means.
Okay.
Okay, now what if I said 32 times 10 to the power of 1? What's that?
Then it's just 10. It's just 320.
Exactly. In other words,
Okay.
there's nothing magical about scientific notation.
Okay.
You know exactly what this number is, and you can multiply it by that number. The only thing magical about scientific notation is this number has to be between 1 and 10. In other words, the way I have written this number is not scientific notation. It's just a 32 times 10 to the 1 power. If I insisted on this being in scientific notation, I would have to write it like this. Because this number right here has to be greater than 1, greater than or equal to 1, and less than 10.
Okay.
Okay, notice that what I get is 3.2 times 100, which is the same number.
Okay.
You got it?
Got
I
that.
think so, yeah. Okay, what else you got?
This one is first set of parentheses 6.1 times 10 to the power of negative 3. And in the next set of parentheses, it's 8 times 10 to the power of 9.
Take them one at a time. Take the number part. By the number part, I mean 6.1 and 8. What does that give you?
6 times
What's 6 times 8?
6 times 8 is 48. Okay.
There's the number part. Now what's the 10 part?
There'd just be 10 to the power of 6.
Okay. That's the correct answer, but it's not in scientific notation.
Okay.
Because that 48 needs to be a number between 1 and 10.
Okay.
So how can I write this in scientific notation? I can move this decimal point 1 to the left. What does that do to this part?
The exponent has to be higher
By 1.
by 1. Okay.
So those
So every decimal.
Those are the same two numbers. This number and this number. The only difference is the bottom one is in scientific notation. The top one is just a number. It's not. It's as good a number as the bottom one. It's just not in scientific notation.
Okay. Okay, the next one is in the first set of parentheses, 6.4 times 10 to the power of 7. And then that's over another set of parentheses, 1.6 times 10 to the power of 5.
Okay. Same thing. Do the number part first.
But do you still multiply or do you divide this?
No, you divide.
Okay, so it's 6.4 divided by 1.6.
Which is 4.
Okay.
Times 10 to the what?
Power of 5. Would you just subtract them or add?
Subtract the exponents when you're dividing. Always remember that when you're dividing, when you're doing something same base, different exponents, you're going to do one level less mathematically. We are dividing. One level less than division is subtraction.
Okay.
So when I'm dividing, and it doesn't matter whether it's scientific notation or not, if I have 10 to the 7th over 10 to the 5th, that's 10 to the 2nd.
Gotcha.
If I'm multiplying, 10 to the 7th times 10 to the 5th. I'm multiplying. One level less than multiplication is addition. So I'm going to add the exponents.
Okay.
If the third rule, and the only third rule you have to remember, is if I am double exponentiating, like this,
Mm-hmm.
well, what's one level less than double exponentiation?
And double X inspiration.
The multiplication.
Okay.
So that's all you have to remember, is that when you have the same base, either multiplying, dividing, or exponentiating, you do to the exponents one level less than you're doing to the number.
Gotcha.
And multiplication is one level less than double exponentiation. Just like addition is one level less than multiplication. And subtraction is one level less than division.
Okay. Okay, so this one is in the first set of parentheses, 3.9 times 10 to the power of negative 5. And then it's all over in the first set of parentheses, or 7.8.
I was sure it was going to be 1.3. 7.8 is almost as good. That's actually a better problem.
Okay. 7.8 times 10 to the power of negative 8.
Okay, handle the numbers first. What's 3.9 divided by 7.8?
3.9 divided by 7.8. Is that 3 times?
You should have a calculator in front of you when we have a session.
Okay, sorry about that.
That's all right. I mean, it'd be nice if you could do that in your head, but if you can't, you need to have a calculator handy.
Okay. It's 0.5.
Okay. 0.5 times 10 to the what?
10 to the, you're subtracting a minus.
Right, so it's a minus 5 minus a minus 8.
So could you just change the symbol to a plus thing? No.
Yeah, you tell me how to do it. What's minus 5 minus a minus 8?
Would that be just negative 13?
No.
Oh, would it be negative 3?
No.
Positive 3?
Yeah. In other words, these two minus signs become a positive sign. So it's the same as this. Minus 5 plus 8.
Okay.
Whenever you have a positive and a negative number that you're adding together, you subtract them and put the sign of the bigger number.
Gotcha.
That becomes positive 3. So that's the exponent. Positive 3, is that scientific notation?
Yes.
No.
No.
This number has to be between
Or
1
greater than
and 10.
1.
So how do I do that? How do I turn this into scientific notation?
Could you move it to be 5.0?
Huh?
And,
What do I have to do to that exponent? Do I have to increase
Add
it or
one.
decrease?
no, decrease it, my bad, by 2.
You're right. Decrease it by 1.
Okay.
You decrease it by however many places you had to move the decimal point. I only had to move it by 1. In other words, this number is 500. Well, this number here is 0.5 times 1,000, which is 500.
Gotcha.
So you can always do that little test to figure out whether you need to add or subtract an exponent.
Okay.
Okay? So this would be your answer here. If they've requested all answers to be in scientific notation. And one rule that you can almost always assume is they want all answers to have positive exponents. In other words, if I came up with an answer like this, Well, maybe with scientific notation, that's an acceptable answer. That might be. But typically, when they have you work with exponents, there's usually an instruction that says make all your exponents positive. So this number that I've circled here would be the same as, well, that's 1 over 5 times 10 to the positive 2, so that's 1 over 500.
Okay.
What else?
This is a word problem. Okay. It says in 2012, on average, about 9.46 times 10 to the power of negative 1 pounds of potato was produced for every 2.3 times 10 to the power of negative 5 acre harvested. It says how many pounds of potatoes on average were produced for each acre harvested.
Okay. So we have, this is the total amount of potatoes that was produced. This is the amount of acres. So to figure out pounds per acre, what would I do? I would divide, right?
Right.
In other words, if I have 9.46 times 10 to the minus 1 pounds over 2.3 times 10 to the minus 5 acres, the thing is to make sure you end up with pounds per acre.
Okay.
And I do. In other words, I can handle this number divided by this number, and then I can handle this number divided by that number, and then I can handle pounds per acre. So if I start right off with pounds per acre, that's what I'm looking for. So all I have to do is this part.
Gotcha.
What's 9.46 divided by 2.3?
It's 4.11304344783.
They probably want you to round it off to some number.
Yeah, probably to the nearest 10.
Is that what they said?
Yes.
Okay, then that's what that's equal to.
Okay.
What's the 10 part?
Okay, my bad. Minus it's gonna be positive 4, right?
Good.
Okay.
Is that scientific notation?
Yes.
Yes, it is, because 4.1 is between 1 and 10.
Gotcha.
I don't have to adjust it.
Okay. Awesome. Okay. Some more expressions using exponents.
Sure.
Okay. So it's 10 to the power of 0, r, minus 11, minus the exponent of negative 11.
Like this?
Yes, my bad, I'm so sorry.
All right.
S, and then that's over 3 to the power of 2.
What's 10 to the 0 power?
1.
So now I have r to the minus 11, s to the 1. What's 3 squared equal to?
Sorry?
What's 3 to the power of 2 equal to?
Oh, 9, right?
Huh? Now, this is one of those problems where this is what we get as an answer. But I'm betting that in the instructions it says, give your answers with all positive exponents.
Yes.
Okay, so how do I turn that negative 11 into a positive exponent?
You have to put it in the denominator. So it would be 1, or my bad, rs over, sorry, my bad. That would be r to the power of 11.
Exactly. The same expression, only now we have nothing but positive exponents.
Okay. But if it said if it didn't say you have to write your answers in positive exponents, you could have left it at the.
Yeah, there's nothing wrong with that. Well, I don't know about that. Math is kind of funny. It's kind of like having irrational denominators. In other words, that's a perfectly fine answer, but they don't want you to give irrational denominators. They want you to rationalize that so that it becomes square root of 2 over 2, which has a rational denominator.
Gotcha.
Kind of the same thing with exponents. They do not like answers with negative exponents. They don't mind giving you problems with negative exponents, but they don't like answers with it. So very seldom is that going to be, if you had like multiple choice answers, you're not going to find this answer on your multiple choice. You're going to find this answer.
Gotcha.
It's just better to use positive exponents when you can, especially since it's pretty easy to do. So all you have to do is to move it to the other side of the fraction bar, right? So it's not like it's tough to do. It's not nearly as hard as rationalizing a denominator.
Gotcha. Okay, the next one is 4 to the power of negative 3, a to the power of 0. Excuse me. All over b to the power of negative 7.
Okay. What's a to the power of 0?
1.
Let's just erase that then. Now, what can we do really quickly to simplify this so that we have nothing but positive exponents?
Oh, can we just switch the...
You got it.
Things? Okay. So it would be b to the power of 7 over 4 to the power of 3, which is 16, right?
Not quite. You do want to simplify it. In other words, whenever you can simplify a number like this, you want to do it. You don't want to give the answer as 4 to the third.
Okay.
What is 4 to the third?
32.
Multiply it together 3 times. What do you get?
4 times 4 is 16. 16 times 16.
Oh, 16 times 4.
Oh, my bad. 16 times 4 is 64?
Yeah.
Okay.
So that's the answer you want to give.
Okay.
In other words, simplify whenever you can and make exponents positive wherever you can.
Gotcha. Okay, this one is p
P?
to the power of negative 8.
I'm sorry, I didn't hear your first letter.
Oh, p to the power of negative 8. All over 7 to the power of negative 2. Q to the power of negative 9. So can't we just do the exact same thing?
Yep.
Okay.
You had no idea this was this easy, huh?
Yeah, no, when I see that, I freak out, because...
So what's my answer?
7 to the power of 2. And then be q to the power of 9. And that would be over p to the power of 8.
And there's one last simplification.
Okay.
What is it?
Be doing the exponents times the number. 7 times 7, right?
Yep.
It's 49.
There's the answer. We can't simplify it anymore, and we have all positive exponents.
Okay. Okay. This one, it says in parentheses, negative w to the power of 3 over 6. And that's the end of the parenthesis. To the power of negative 2.
Okay. What does that negative 2 apply to?
The exponent?
The parentheses makes all the difference in the world here.
Okay.
In other words, if I have a over b squared, that's the same as a squared over b squared.
Okay, so you apply it to the 6.
Apply it to both.
Okay.
Okay, so let's apply it to both. What do we end up with in the first step?
Okay, would you, since you're multiplying...
And it also applies to this negative sign.
Okay.
So, first step is to multiply that times that and multiply that times that. And leave everything in the same place.
Would the top one be w to the power of 5? Negative w to the power?
Negative 6. Remember, we're double exponentiating.
My bad, I forgot.
So we do one level less than double exponentiation, which is multiplication. And I still have this negative sign, so I got to put parentheses around it like that.
Gotcha.
And then what goes in the denominator?
That would be negative 2.
No?
What? Oh, sorry, I was doing it in my head.
6 to the negative 2.
6 to the negative 2.
Okay. Now, turn it into positive exponents.
Mm-hmm. So, you just switch it?
Uh-huh.
Okay. So it would be 6 to the power of 2 over w to the power of 6?
Negative w to the power.
Oh, negative w, my bad.
Okay. Now, I can still simplify this. What's 6 squared?
36.
What's negative w to the 6th power?
That would be w to the power of 6?
No, w to the power of 6.
Okay.
In other words, when you take a negative number and you take it to an even power, that's the same as negative x times negative x, which is positive x squared. So whenever you take a negative number to an even power, you basically get rid of the negative sign. If I took negative x to the 3rd power, an odd number, that's going to be negative x times negative x times negative x. So when you take a negative number to an odd power, it's still negative.
Okay.
So the fact that we're taking negative w to the 6th power, an even number, is the same as w to the 6th power.
Okay.
In other words, if I had negative 2 to the 6th power, well, that's negative 2 times itself 6 times. That's 64, but because you have negative 6 times, it equals positive.
Okay.
Okay? So it all depends on whether it's a even or an odd exponent as to whether you carry the negative forward or leave it separate. Now, it's worth noting that this is different. Excuse me. If I wrote that, well now the 6 is only operating on the positive 2. So it's 64, and I still have that negative sign. So it's that. So where your parentheses are makes a huge difference.
Gotcha.
There is a big difference between this and this. This one's equal to what?
2 times, it's negative 4.
Bottom one's equal to what?
4.
You got it.
Okay.
In other words, the exponent only operates on whatever is in the parentheses. Or if I don't have parentheses, then it only operates on whatever is below it.
Okay.
And that's key in dealing with exponents. Definitely want to know that. All right, what else?
Okay, this one is sorry, my bad. In parentheses, negative 5b to the power of 3. And then end of parentheses and to the power of 3.
What are we doing here? What's this called?
Would you just distribute?
Double exponentiation.
Gotcha.
Okay. So first of all, this 3 up here applies to everything in the parentheses. So what is minus 5 to the third power? We'll take the number part first. We're going to take this part here. What's minus 5 times minus 5 times minus 5?
Positive. Would it be positive?
No.
Or negative 125.
Exactly.
Okay.
So that part is negative 125. And now let's apply it to the p cubed. What's the rest of it? What's p cubed cubed?
It's going to be p to the power of 9.
Good.
Okay.
Because we're doing double exponentiation, we multiply
Gotcha.
exponents. Now,
But doesn't it have to
let me
be?
just give you a little test here.
Oh, okay. My bad.
What's that?
So first, would you do the 3 to the power of 4 and 3 to the power of 5?
Uh-huh. Well, what are we doing? We're multiplying, right?
Right.
So what do we do with the exponents?
Oh, you add them.
What's this?
That'd be 3 to the power of 5.
And finally, what is this?
3 to the power of 6.
You got it. Those 3 rules. Remember them. Do not forget them. You will need them every math level you take from here on out.
Okay.
Okay? All right. What else you got?
Well, going back to the last problem, it's like negative 125p to the power of 9.
Yeah.
Shouldn't it be positive though? Or does the exponent
Well,
only have to be positive?
we're going to take the number first.
Okay.
We're taking negative 5 to the third power. In other words, let's take this piece by piece. Whenever we have something like this, it's the same as negative 5 to the third times p to the third to the third. In other words, I apply the 3 to the negative 5, and I apply the 3 to the p to the third.
Okay.
So negative 5 cubed is still negative because it's an odd exponent. And p to the third cubed is very simple, multiplication, because I have double exponentiation going on there.
Gotcha.
So with these 3 rules, you're going to be able to handle anything they throw at you.
Okay.
Doesn't matter how complicated or how many variables. I could put 25 variables in the numerator and the denominator, and you just want to take them one at a time.
Gotcha. Okay, this one is, in sub parentheses, 1 over 2r to the power of 6.
Like this.
No, my bad. It's is inside the parentheses. It's r to the power of 6. 2r to the power of 6.
Like this.
Yes.
And
And on the no, the 6
No,
is not.
okay. So the 2 is not being taken to the power of 6.
No,
Okay.
it's the r.
Is that it?
And then it's no. That entire thing's in parentheses, and it's to the power of negative 6.
Like this?
No. The entire thing, the entire fraction, with everything in it is in parentheses.
Okay. Like that.
Yes, but there's also a positive 6 to the next to the R.
Oh. Like this.
Yep.
Okay. Well, first of all, the biggest rule we need to remember is that A over B to the x is equal to A to the x over B to the x.
Okay.
So I can start off by applying this negative 6 to the numerator and the denominator separately.
Gotcha.
Just like I have down here. Okay, so when we apply it to the 1, what is 1 to the negative 6th power?
Negative 6.
Nope. What's 1 times 1?
1.
What's 1 times 1 times 1?
1. Oh, it'd just be 1.
Yeah. 1 to any number is 1.
Okay.
Positive or negative. I could say 1
Negative.
to the negative 3. That's still 1 over 1 to the 3, which is still 1 over 1. So it stays positive, even though it's an odd exponent. It's not like it's negative 1 to the third. Okay.
Okay.
So that's the numerator. What about the denominator? I'm doing double exponentiation. So what am I going to do?
Multiply the.
So
It's going to be
I got 2 to the negative 6, because the 2 is inside the parentheses.
Right.
And then R to the what?
To the negative. No. Yeah, negative 36.
Yep.
Okay.
Now simplify it.
Would you just flip the fraction? Okay. So
Well,
then it
flip
becomes.
the bottom. I mean, you can flip the top because 1 can be flipped without changing its value. But that's the only number that can be flipped without changing its value. So you're right. I should really flip everything. I get 2 to the 6th, R to the 36th, over 1. Well, I don't need the 1 in the denominator, so I can erase that. 2 to the 6th is 64. And if you want to memorize anything at all, it's powers of 2. It would be really helpful in your math career to know what 2 squared is, 2 cubed, 2 to the 4th, 2 to the 5th, 2 to the 6th, 2 to the 7th. I would say up to 2 to the 10th. Now let me tell you why. 2 to the 4th is 16. 2 to the 5th is 32. 2 to the 6th is 64. 2 to the 7th is 128. 2 to the 8th is 256. 2 to the 9th is 512. And 2 to the 10th is 1024. And that's a good one to remember, that 2 to the 10th is about 1,000. There's something else very special about these numbers. You know what it is?
They add to each other.
No, it's...
Multiply it times 2.
No, you're probably not going to get this. You're not going to get this because you're not old enough. Okay? When computers, personal computers, were being developed, you had 16 meg, you had 32 meg, then they went to 64 meg, and then they went to 128 meg, and so forth. Why is that? Because computers are based on binary, base 2. So every time they make an increase, they go up by a power of 2. So now we're way beyond that number. We're into gigabytes and terabytes and petabytes. But these numbers are key. You'll notice that if you examine the history of computers, those were always big numbers. When I was close to your age, it cost $10,000. No, it cost $1,000 to get an extra 10K.
No way.
Yes way.
That's crazy.
It is crazy. $1,000. When I had my first personal computer, it did not have a hard drive on it. You had floppy disks. And they came out with this 10 kilobyte hard drive. And it was $1,000, and it was well worth it. Because if you put it on your computer, you could store all of this data where you could only fit 320K on a floppy disk. So these numbers were very important. And it shows you the power of Moore's Law. Moore's Law says that computing power doubles every 18 months and half price. In other words, if you can now get 1 meg for 500 bucks, 18 months from now you're going to get 2 megs for 250 bucks. That is the progression of computer power that has happened over the last 20 years.
That's pretty cool.
It's really cool. And it also shows you what's going to happen 20 years from now if Moore's Law stays in effect.
Now how did it stay in effect? Like,
it's just the reason of technology. In other words, because they can shrink the size of the circuit board relatively easy, technology has allowed us to build stuff smaller and smaller. That's the biggest reason why Moore's Law is in effect, is that 18 months from now they can build something twice as big, the same size, and for half the cost. And of course what that means for the future is that the power of computers 20 years from now is almost going to be unfathomable. That's why they think artificial intelligence is a no-brainer, because of Moore's Law. Moore's Law basically says that computers are going to reach a power that's way beyond what we can even conceive of very quickly.
Great.
All right, what else you got? Didn't mean to get distracted. You got another problem? We just haven't been.
Oh, it's fine. We can just end there if you want.
Okay. You don't have any last questions? I think you're good.
Yeah. Yeah, I think so.
If you can remember those 3 rules for exponents, and most importantly, remember that negative exponents have nothing to do with negative numbers.
Right.
In fact, as long as x is positive, this is always a positive number.
Right. Awesome.
All right. Good going, Connor. I'll talk to you next time.
Okay, thank you so much.